Let us now discuss how can we solve this problem. Find closest person. So this is a simple easy problem, right? You are given three integers x, y, z. Now, representing the positions of three people on a number line. X is the position of person 1, Y is the position of person 2, Z is the position of person 3, who does not move. So, here X is person 1, right? And Y is person 2, and Z is person 3. Okay. Now, determine which person reaches person 3 first. So, person 1 and person 2 move toward person 3. Person 3 at same speed. Person 1 and also person 2 move at the same speed. Right? Now, determine which person reaches person 3 first. Return 1 if person 1 arrives first. So if person 1 arrives first, then we need to return 1. If person 2 arrives first, then return 2. Now, return 0 if both arrive at the same time. So if both arrive at the same time, then we need to return 0 at this point. Now let us look at some examples. X is equal to 2, x is equal to 2, y is equal to 7, z is equal to 4. So let us take this on a number line. 1, 2, 3, 4, 5, 6, 7, 8, 9. So at 2 I have x, and at 4 I have z, and at 7 I have y. At 7 I have y. So X moves two positions, right? So two positions as they move in the same speed. So X takes two, or person one. X is nothing but person one takes two as the time. Now Y takes three. Person 2 takes 3. Now, person 1 is taking less time, so I'll return 1 there itself. Now, let us look at the second example. X is equal to 2. So, let's take this in a number line 1, 2, 3, 4, 5, and then 6. So, x is equal to 2, y is equal to 5. X is here, y is here, and z is at here. So y is moving only one position. So person 2 is taking only one. X is moving one, 2, 3, and then 4. So person 1 is moving 4 steps, right? So person 2 is nearer to z, so we'll return 2. Now let's look at the third example. X is equal to 1, y is equal to 5. Let's take this in a number line 1, 2, 3, 4, 5, 6. X is at 1, and y is at 5, and z is at 3. So x takes two values, two spaces or two units. So person 1 is equal to 2. Y takes 2. So person 2 is also equal to 2. Now, both are taking same values or same steps. So we'll return 0 at this time. So if you see, 3 minus 1 is giving me 2 here. 5 minus 3 is giving me 2. But what if y is before z? 5 minus 6 will give minus 1. So what I'll do is I'll take absolute value. Absolute of person 1 is nothing but, let us say, x minus z is greater than absolute value of y minus z. That means y is taking less time than x. So if this is the condition, return 1, right? Now, else if absolute value of x minus z, x is taking less time than y, then what I'll return? I'll just return, wait a second. So here, if you see, sorry for this mistake, y is taking less time. That means person 2 is taking less time. So I'll return 2 there. Now, person 1 is taking less time here. X minus z, x is taking less time than y. So here I'll return 1 else. So if these two conditions doesn't satisfy, it means both are taking equal time. So then I will return 0 itself. So this is how we solve this problem. And if you have any doubts, please let me know in the comment section. And we can also even optimize it, but it is not something like taking any time or any space. So the time is nothing but big of 1, and also the space is big of 1. So we can also reduce the number of lines, however, but it is also no need to do. So if you have any doubts, please let me know in the comment section, and please do like, share, and subscribe to my channel. Thank you.